Hello everyone, welcome to StartTech. In today's video, we are going to discuss about Lambda architecture, what are all the interview questions being asked, and how you can ace your data engineering interview round for this kind of questions being asked. So let's dive into it. So these are the topics which we are going to discuss. What is Lambda architecture? How it works in practice? What are all the common interview questions? How you can ace your interview with the sample answer for the same? And finally, the summary. Okay, so before diving into the Lambda architecture, we'll discuss what are all the data pipeline process being involved. So this I have considered it as a batch processing system. So in general, in a batch processing system, you have a input data, which may be a flat file or database. You have a batch layer where you are writing a Spark job, you are doing some transformation and dumping the data into a table or a view, and that you are serving it via Impala, or if you are on the AWS cloud, then maybe an S3 or a Redshift. And finally, you are exposing those tables or views via Tableau, Power BI, or ClickSense, whichever it may be your downstream systems. So now that we have understood like what exactly a data pipeline is in a big data world, let's see why we need a Lambda architecture and what exactly is a Lambda architecture. So as seen in the previous slide, that we have a batch layer. Now we require this speed layer. Why? Because uh, consider that your data pipeline has both the layers. You have a batch layer system as well, and you have a real time feeds coming or events coming to a topic on the Kafka, or you have some real time data coming in. So that will be processed using a speed layer in a Lambda architecture, and both the batch and the speed layer in the serving layer final output table will be integrated, and that integrated table will be finally shown to the output layer, maybe a Tableau or a Power BI or a ClickSense system, whichever it may be in your downstream system. So that is the reason when we want both kind of systems, like we want batch processing as well as your real time data to be processed. That can be processed using Spark Streaming, Flink, Kafka, maybe Amazon Kinesis. And regarding the batch layer, it may be your Spark Glue job, and final layer maybe serving layer, maybe S3 or an Impala or an Redshift table. And these tables will be finally exposed to your downstream system. So yeah, that is what exactly Lambda architecture is. So we'll see in a real world example. So let's take that you have an IoT based smart metering system. Okay, so you have maybe 3 years of telemetry data in S3 and process daily with AWS Glue and Spark. So this can be your batch processing system, and your speed layer will involve real-time readings from an MQTT topic using Apache Kafka and Spark streaming. And finally, the service layer will combine both your real-time and your historical, showing your today's and historical combined result or output. Tools may be used, maybe it may be a plus S3, Kafka using Spark streaming, and finally it may be a Redshift or a Druid table on the finally on your dashboards. So as we discussed till now, this can be your um, framed answer for the question being asked, like what is Lambda architecture. So you may say like you are currently using Lambda architecture in your current project, And Lambda architecture separates your data processing into batch and real time system. And currently, in your current maybe energy analytics project or whichever project you might be working on, you may take up that name and say that yes, we are using Lambda architecture in our current data frames or in our current project, and how you are using it, you need to explain in that way. So here is an example how you can tell that you are ingesting 5 TB of data, which is a telemetry data, and for batch processing you are using Spark plus EMR, and for speed layer you are using Kafka with Flink, and finally you are exposing the final combined result to an API powered by Druid in the serving layer. And this hybrid approach helped us to deliver accurate historical insights and the real time alerts to our final customers. Here you can also mention like what all challenges you faced for implementing Lambda architecture. So that is a bonus tip for you. So, what are all the pros and cons of a Lambda architecture? So, Lambda architecture supports both historical as well as real time data processing. It is fault tolerant and scalable, enables event time and processing time analytics as well. So these are some of the pros of Lambda architecture. Then what are the cons? So cons are basically uh, we have to duplicate the data for both the batch processing as well as speed processing, which involves higher maintenance of syncing the output of both the two pipelines, right? And replaced Lambda architecture via Delta, Delta Live Tables, Kappa architecture that we will see in our upcoming videos in this channel. So stay tuned. So here we will discuss more of the questions, okay, and answers what you can tell to the interviewer, right? So basically, whatever we till now discussed, like what is Lambda architecture and what are all its components. So you can tell them that you have a batch layer and a speed layer and a serving layer, which does the job to expose your final data mart to your downstream application, right? And how is it different from Kappa architecture? So this we'll discuss here. So here, the main difference lies in handling the batch and real time data. Lambda architecture maintains separate layers for batch and speed, leading to some duplications of the logic and complexity. While in Kappa architecture, use a single stream processing layer only. So in Kappa architecture, we are not handling our historical kind of processing. So, and in real time data replaying events like Kafka events or maybe uh, like Kafka events, and in Kappa architecture often preferred for simplicity and maintainability when batch logic can be replaced with the stream processing logic. Right, so this is the way you can handle this question. And what are all its pros and cons as we discussed, right? It is accurate historical analysis and it low latency. Con could be like you are replicating the code, so it is higher in maintenance, right? So this we have discussed, and how you can handle data consistency between batch and speed layer. So data consistency is typically achieved by using event time and watermarks to align the data in both layers. So applying idempotent writes and deduplication logic is how you can achieve this. So, having a reconciliation step where batch results override or clean up the real time data. This is how you can handle this data inconsistency between these two layers. So you can explain this how you are handling it in your current project if you are using, or you can mention whatever we just discussed as a framed answer for this question. So, can you describe a project where you have implemented? So, as we discussed in the previous slide, this you can mention like you are ingesting some MQTT data as well as some historical data, and finally, you are integrating the data using a speed layer, and then finally, the downstream application you are exposing that table, and that is being visualized using the downstream applications and all. Okay, so these are the commonly asked questions and specific answer to those questions. So moving on to the next slide. So yeah, so here we have considered all the topics which we had planned. And so Lambda architecture may be a legacy pattern, but it is good to know at you know how the data evolution and the processing happens at the back end. And it's always a good tip to answer this question using a diagram and real life example which we discussed, and tools and stacks which mentioned like Kafka with Spark, HDFS, Cassandra, etc. And trade-offs between Kappa architecture and Medallion architecture. This also you can mention. If you have not seen the video of Medallion architecture, I have posted it in my previous video. So please watch through those videos as well. And finally, thank you very much for staying till the end. Please like, share, and subscribe, and also comment down below which topic you want to see videos on. Thank you very much. Bye bye.